This is an instructional video for people in the United Kingdom and Europe using translators and etheric cloudbusters. Now, this is Earth Nulschool, the wind satellite information. What it will give you is moisture content at different heights. It will give you the wind directions, it will give you the wind velocity, amongst a few other things like air pressure, etc. So let's keep it simple. First of all, you can zoom in onto it and you can zoom out. One of the facilities which is very useful is looking at the moisture content. So let's keep it simple and look at the UK. Now, we've zoomed into one spot. That's where I've been pointing, by the way. That's the cloudbuster. If you go to click Earth at the bottom left hand corner, you have this page that comes up. So height, SFC, these are heptapascals, and you'll notice as you go from 1000 you go to the right, the figure drops. The figure drops because as you go upwards into the atmosphere, the pressure drops. So heptapascals are air pressure figures, not pounds per square inch. So you're at 1000 at ground level, 850 as you go higher, and so of course the wind directions will change as you go higher. As you go up to 150, click on Earth, that takes the box back. You can now see the wind directions, strong winds there, just to the left of Iceland, southern states and the northern Atlantic. Go to 700, we're now seeing the bottom of the jet stream, diverting around the UK from a previous deployment. As you go higher up to 500, now you really are getting into the jet stream at 30,000 feet plus, and 250, you can see how the jet stream is reacting, and the deeper the red, the faster the wind. So you could be looking at 200 kilometers an hour in the wind, and then you start getting into the upper atmosphere where the winds slow down and smooth out because the air is very, very thin. It's unusual that we've got strong winds right in the upper atmosphere there, but you can see, you get the gist of it. The higher the figure, the lower you are in the atmosphere. Now here's another one. Let's take it back to 1000. Another one is called, is it the TPW? Just let me check on this because we'll go back. Yes, it's this one here. This is the moisture content per square meter from ground level right to the top of the atmosphere. So if you could imagine a pillar going from the Earth right up to the top of the atmosphere, this is how much water is contained in that square meter pillar. 39.40 kilograms of water content. Okay, so nearly 40 kilos of water where you click. So for example, right over there in central England, we've got 18 kilos of water available in the atmosphere right up to the top of the atmosphere. Where it's blue, so if you click there, it's higher because you've got 31 kilos there. Now we've been deploying on India, so we'll zoom out and we'll come to India. Now here is India. We know somebody's been deploying in Sri Lanka. There's plenty of moisture here. We've got 60 kilos of water in that column above India. If we look under central India, we've got 15. And we've got it 15 or 16 kilos. Very little water to react with on an etheric charge. So here's why we've got 50 to 60 kilos here. And this is why we're putting a block here. Now, we can go down, that's at ground level. If we start coming up slightly higher, this is where we are blocking. Now, interestingly, we have 3 vortexes and 3 deployments. These are your deployments here, causing blockages. But look what's happening to the moisture coming from this area here. It's now turning right and heading towards India, and we want that to continue north. Because of the high temperatures, the moisture will dissipate quite quickly. However, since our deployment, temperatures are starting to fall. Heading west generally drops temperatures, especially at your target, and that's exactly what is happening. So let's go into the there's a description which is always useful to fall back on if you need to know and double check what to do, and it's here. So from this page you click on Earth and it says About. You click About. Now the details come up, and there's lots of other things. It's worth playing around with this. You will discover a lot of things. It explains things here. Now, here is your description of your heights. 1000 hectopascals. Remember, the lower you go, the higher the pressure, is 100 meters near sea level. 850, now we're going up in the atmosphere, that's 1500 meters. 700, the pressure's dropping more, 3500 meters. 500, 5000 meters. 250, as it says there, the jet stream. 70 hectopascals is 17,500 meters, which is 60,000 feet above the stratosphere, and then you're going right up into the upper stratosphere towards outer space, or a fair few miles short of that. There's still atmosphere up there, but you get the general opinion. That's how high you can go. So now we are going to look at, there was another one, moisture, which is TCPW, total precipitation of water, and it takes you to Wikipedia if you trust it, and it will precipitate water. It explains. We know the etheric charge controls this, but if you want to read that, feel free to do so. So that's quite simple. Do it 2 or 3 times and you'll get the gist of it. So notice as you go to different heights, the moisture content can be slightly different. But it's interesting to see there's a lot of moisture at the south of India right now, and that's what we need to do, is to get that up to central India, and that will create precipitation and rains, which would be very welcome for the farmers who are having a catastrophic time at the moment. Now, these are the actual deployments that we've set up. 101 degrees from the UK on the compass, 22 degrees declination, which is there forming this blockage, and 2 other translators are looking at that area slightly lower, and even lower still we've got Debbie now even lower. So when the winds come this direction, you can see that they will go up into India, and that's exactly what we've seen on the satellite to the south of India. Now this is the result of the deployment so far. The blockage is down here, so you can see that's now turning and head slightly north. Where the blockage is, some of it's headed south. The blockage here is pulling this up, and from behind the vortex we've got a slight drop to the south here. So we're interested in getting this here to head further north. We will see how things progress in the next 12 to 24 hours, and then we may have to do a further deployments in a different area for the catchment of moisture to head north. Now we can see quite an increase here below the middle of India from Sri Lanka. We have Drew here who deployed 2 days ago and caused a small thunderstorm to the south, and we can monopolise on that. You can see how moisture's just been created from almost nothing. That was the cloudbuster deployment over Sri Lanka that we've done a video on.